Okay, so this is video number 3 of the ABC of fire alarms. So far we've done A through to L. We finished off with loop and the difference between loop and a radial system. And now we're going to talk about M, N, N, O, P, E, Q and R. So starting with M, maintenance. So a fire alarm system, whether it's an analog adjustable system, a radial system, a conventional system or a radio system, all fire alarm systems have to be maintained. So the British standards for maintenance is 5839 Part 1 2013, and in there it tells us how to specifically maintain a fire alarm system. But I'm going to show you the basics using this panel right now. So if this was a fire alarm system in a building and we are a maintenance engineer sent to do a maintenance visit, over a period of 12 months we have to maintain the whole of the system. So if this was the whole of the system, representing 100% of the system, we would have to test that all of this works over 12 months. Now we can either do it every 6 months, 50% to each visit, or we can do 25% over a quarter, so 25%, 25%, etc, etc. But we have to do 100% in 12 months. In the simplest terms, the way you maintain a fire alarm system is you have to test that all the devices physically work. So you either smoke the detectors, actuate the call points and apply either flame, heat, etc. to the detectors to prove that they all work. And to prove that they work, when they work, they bring up information on the screen. And that, in a nutshell, is how to test the test the devices. The other test that you do is you measure the battery voltage on both batteries to ensure that the batteries could carry on running the system if there was a power cut. And if there's anything else connected to the system, like door release magnets or other relays or switches, you have to test those. So the maintenance is just like a maintenance of a car or any other kind of electrical item. You test it to make sure that it's going to function, going to do what it's supposed to do. So that's maintenance. So in our industry we have non-conformities. These are when things go wrong. So if a panel, when you're testing it, doesn't work, a detector is broken or it doesn't activate, we would put that on our forms as non-conformities or near misses and things like that. So non-conformities are basically things that go wrong. O is for optical detectors. So there's basically 2 forms of detectors which detect smoke in our industry. One is an optical detector and the other is an ionisation detector. An optical detector uses basically a laser beam and an eye to sense whether smoke transfers into a chamber and then sets it off. So if my eyes were the optical sensor in the detector and I look forward and I see nothing, then that's good. As soon as smoke wafts through my eyes, I see that's a problem and I register the activation. And that's basically how an optical smoke detector works. With an ionisation detector, it has slightly different characteristics. It doesn't use eyes, but it senses the movement of the smoke in a chamber that is basically a vacuum. It's a sealed chamber. So ionisation detectors work by sensing the smoke as it comes into the chamber, making the ionisation chamber work harder. But we'll discuss that in a practical demonstration. So optical detectors are detectors like this, which use a pair of eyes looking forward, and when the signal is obstructed, it flips a switch. Up here, you've also got another optical detector, which is the beam detector. And what that does is that shoots a beam from here all the way across up to a reflector, which is up here, and back again continuously. And all the time that that's working, there's no problems. However, when you obstruct the detector, which this may work, depending on whether it's going to activate or not, typical really. When you obstruct the detector, then the detector goes off. But we'll show you that one on the practical demo. So that's O for optical. Skipping P and moving on to R. So R is for radio kit. So we talked in the last video about analog addressable systems and conventional systems having cable, fireproof cable. So let's just remind ourselves what the cable looks like. So fireproof cable is red It's fireproof, waterproof and mechanical proof, and it's wired in a big loop or fingers of radials. Okay? However, in our industry we have radio devices. So these are devices that don't need cables. They look very similar, or they can look very similar to these devices. So for example, this is a radio detector. So it does look a bit similar to this one here. But the difference is that rather than having cables, it has batteries. So a radio device, or an EMS, which is one of the main manufacturers, a radio device has batteries in it and not cables. The radio panel looks very, very similar. And over here you have some boosters which send on the signal to other parts of the fire alarm system. But a radio system basically uses no cables whatsoever. Okay. So then finally, S for this video. S is for service engineer. So a service engineer, as the job that is being currently filled by you, Dean. The service engineer's responsibility is not only to test the system, but also to learn the system and learn the design codes so that we can spot any mistakes. So there's lots of things to learn on a fire alarm system, and it's the engineer's responsibility, as laid down in the codes, to comment at the time of the maintenance visit whether the things are right or wrong. For example, the most common mistake is when you have a detector and it's fitted to a ceiling, but it's too close to the ceiling. So for example, it's only a couple of centimetres away from the wall. In our industry, that's not allowed. It may work when it's tested, but the engineer is meant to let the customer know on the form that actually that's non-compliant or a non-conformity. So a service engineer's job is incredibly important because ultimately this bit of kit saves lives, and the service engineer makes sure that that bit of kit does its job. Recently we've had a fire in one of our properties that we look after up in Clapham. It hit the news. It was a total destruction of a private school. Luckily no one was injured or died, but our fire alarm system worked. It rang the bells, it alerted the members of the staff who called the fire brigade, who turned up. Now in this instance the fire brigade turned up. There were 57 firefighters, 15 fire engines, and it took nearly 4 hours to put the fire out, and they lost the whole building. But our system alerted them to that fact, and then nobody was injured or nobody died. So a service engineer's job is a very serious job, and ultimately it saves lives. So that's it for S. We'll continue on the next video and the penultimate video from T all the way through to Z, and then we'll finish up. We're doing the practical demonstration on the 11th. That's it.